Hello, grade 7 students. This is day 23, page 452, numbers 5 through 25, the odds. Today's lesson is about misleading graphs. You'll notice that on page 450 and 451, there are a number of graphs. There's also some on 452 and 453. I'd like you to take a look at those pages, pause this video in a few seconds, read through it carefully, and then let's talk about it. Go ahead and pause it now. Okay, welcome back. Wondering if you understood what was going on here. If you look at the top of page 450, they have two graphs that even though they don't look identical, they're showing the exact same information. Did you understand that? Both graphs are showing money spent per person for tickets to the movie theater. Can you look at graph A right now and look specifically at the left side of the graph? The y-axis, the numbers go from 0 to 10 to 20 to 30 to 40. And now look at graph B on that same left-hand side. The numbers go starting at 28, then 30, then 32, then 34, then 36, then 38. Even though they don't look the same, the graphs are showing the same amount of information. One of the graphs, though, graph A, has a slope that's much less steep than graph B. And the reason why the slopes look different is because of the numbering that's on the left-hand side of the graph. When you have those intervals of 10 on graph A from 0 to 10 and 10 to 20, 20 to 30, and 30 to 40, that's going to create a shallower slope than graph B. So let's imagine that you are trying to tell somebody, hey, my movie theater is doing really, really well. We're making lots and lots of money every year. Would you use graph A or graph B? I think you might use graph B because that shows your numbers going up pretty drastically. Go to the bottom of 450 where you see the two red bars on graph A, and then you see the two blue cars on graph B. Guess what? Those two graphs are showing the exact same information again. Sales of specialty automotive equipment in billions of dollars. Which one of those graphs would you show somebody if you're trying to convince people that sales are going up, but they're not going up that dramatically? They're just going up a little bit. I'm probably going to choose graph A for that. That graph doesn't seem like it's going up tremendously hard. But when you look at those two blue cars, the one car looks much smaller than the other car. But in essence, they're showing the same information. The numbers are the same for both graphs. On the top of page 451, they worked with using mean, median, and mode and trying to figure out how you could use that data to try to trick people or convince people that your data is either better or worse than what you really think that it is. In this situation, they were comparing the ride times of roller coasters at an amusement park. And they found the mean, median, and mode. The mean, the average, was 127 seconds. The median was 135 seconds, and the mode was 150 seconds. So what does that mean? Well, would you rather have a roller coaster ride that lasted for a short amount of time or a long amount of time? Most roller coaster people that love riding roller coasters wants the ride to last as long as possible. So if you want to convince people that your amusement park has really long rides, in this case, you'd probably pick the mode and talk about that with customers because the mode is the biggest of those three numbers. Let's look at a couple of example problems. Hope you can see this. I'm going to bring it in as close as I can. Hope that shows up. we've got graph A and graph B that are showing numbers of television sets. And then off to the sides, it says numbers of television sets per 1,000 people for places like China, Chile, Indonesia, and Saudi Arabia. Now, if you lived in a place like Indonesia, based on this graph, and you were trying to convince people that we need to get more television sets in your country, which graph would you use, even though the graphs are showing the exact same information? I bet you use graph B, because graph B shows that Indonesia is behind Saudi Arabia and China, and it seems like you're behind by a lot. Up here, it seems like the numbers are equal. Even though the graphs show the same information, why do the graphs look different? Again, look at the left side of the graphs. In this graph, they're going up by 100ths. In this graph, they're going up by 25s. And because of that, that makes the bars look drastically different. Okay? Let's look at a little bit different of a problem, a gymnastics problem. It says the scores for girls on a team competing on the vault at a meet are 8.3, 8.5, 8.5, 8.8, 9.0, and 9.2. They want us to find the mean, the median, and the mode of this set of data. Well, if you remember, I always used to look for the mode first because that's the easiest one to find. What is the mode in this set of data? The one that appears most often is 8.5. Let's find the median next. That means putting the numbers in order from smallest to largest. Are they in order from smallest to largest? Yep, they already are, but they're in 2 rows, so that makes it a little bit difficult. I think what I'm going to do is rewrite them right here so that they're all in 1 row. And then let's find the middle number. Bump, bump, uh-oh. We got 2 middle numbers. That means we've got to add these 2 numbers together. That'll be 17.3. And then we need to divide by 2. 17.3 divided by 2 goes... I get 8.65 as my median. Okay, my median is 8.65 because it's the middle number of 8.5 and 8.8. Now I need to find the mean. Do you remember how to find the mean? You add up all the numbers and you divide by the amount of pieces of data, which in this case is 6. There are 6 numbers here. So I need to add all these numbers together. Let's see. Oh boy, am I going to have room here? I don't know. The first 2 numbers would add up to make 16.8. The second 2 numbers would add up to 17.3. And the third 2 numbers would add up to equal 18.2. Now let's add those together. Boom. 14 and 8 is 22. 5, I get 52.3. And we're going to divide by the amount of pieces of data, which is 6 in this case. 6 goes into that. Let's see, 8 times. 6 goes into that. 7 times, 6 goes into that, 1 time, let's round to the nearest tenth, 8.7. So I've got these 3 numbers. I've got a mean of 8.7, a median of 8.65, and a mode of 8.5. Look at the question that they ask then. They ask, which average would the team use to make its results look the best? And explain. Which average would I use? I'd use this one because it's the biggest number. If I want people to think my team's doing really well, I'm going to choose the mean because it's the biggest of the 3 numbers. Okay, take a look in your textbook at problem number 3 on page 451. Problem 3 on page 451. It says, which graph would you use to indicate that Norway had many more medals than the Soviet Union? By the way, the Soviet Union is the old name for Russia and some other territories that have changed names over time. Anyway, graph A and graph B are identical in the information they give us, but the appearance of the graphs is different. Now, if you're from Norway and you want people to think you're much better than the Soviet Union, which graph are you going to grab? I think a graph B would be the answer, wouldn't it? Yeah. What's our explanation? How about this? Graph B's bar for Norway is much bigger than the Soviet Union's. I think that would be a reasonable answer for number 3. Graph B's bar for Norway is much bigger than the Soviet bar. Let's look at number 4. Actually, we're going to skip that. Let's go to the next page. Your assignment, folks, is to work out 5 through 25. If you get stuck, give me a call. Thank you very much. My number is 517-242-3138. Have a great day.